Okay, so let's take a look at this one here. Okay, so here we have two angles and a side. So we're going to have to figure this out. Now there's a few ways we can make our right triangle. We can make a right triangle like this on the outside. So there are times where we could use that. Now if I do that right triangle, I know I can find this angle at 75 degrees, but I don't really have much to work with here. Okay, so that's not really maybe going to help us out too much. Another option is we can draw a line from one of the vertex here and drop it down like that. Okay, and once we do that, we have this triangle. We have 40. This is going to be 50 degrees here, which makes this 55 degrees. Okay, this is not symmetrical, so it's not an isosceles triangle, so we can't say that this other side is x is equal to 9. But we do have an angle, we have the shape, and we have one side, so we can work out the other sides. So I'm going to call this, let's call that m again. That m represents the altitude of the triangle, and I'm going to solve for that. So that's going to be relative to 40 degrees, it's going to be opposite. That's the hypotenuse, opposite hypotenuse, so that's sine. So I'm going to write this as sine 40 degrees. Opposite over hypotenuse, m over 9. So I need to convert that 40 degrees into a ratio. So I do sine 40. That gives me the ratio is 0.6427, so I'm going to round that to 643, is opposite to hypotenuse, and it looks like that. So solving for m, I get 5.785, so I'm going to round that to 79. So that represents my altitude, 5.79. Okay, so I'm going to use that then to figure out the rest of this triangle. So I'm going to start by solving for this side y, okay, and I don't know the whole length of this side, but I know that the partial length from here to here can be found using Pythagoras or trig. I'm going to use Pythagoras. N squared is equal to, it's a shorter side, so I need subtraction, so my long side minus the shorter side squared. So I end up with 9 squared minus 5.79 squared, which is approximately, okay, so when I square root this, I end up with n is equal to 6.89 about. Okay, so about 6.9. So, but I'm going to keep my two decimals here. So 6.89. So I've now solved the triangle on the right hand side, which I'm just going to highlight in red. And I need to solve this other triangle, which I'll highlight in blue. I do know this angle in here. This is going to be 40, 105. So this is going to be 35 degrees. I'm just going to write it on the inside actually. Okay. It is complementary to this 55 degrees as well. And so we have the vertical length here. This is the altitude of this triangle. And then we have an angle. Okay. We can use 35 or 55 degrees. Okay, I should write that in blue because that's part of this blue triangle. So I'm going to solve for the length of x. And the length of x involves, relative to 35 degrees, it's opposite hypotenuse. Opposite hypotenuse is so sine. So 35 degrees, opposite hypotenuse, 5.74 to, 79 to x, which is my hypotenuse. I need to convert that 35 degrees into a ratio, so I end up with 0. From my calculator, 573 0.35, so I'm going to round that to 4. Okay, so I can solve this algebraically. So I'm going to end up with 5.79 divided by 0.574. And I'm getting about 10.09. Okay. Again, if it's somewhere near 10, that's pretty good. Okay, you've done the right thing. So this length is going to be about 10. And then I'm going to find this other side here, which we'll call, let's call this side A. Okay, and that side A, I'm actually just going to work that side out. I did Pythagoras on the red triangle, so we can use, we'll use, in this case, I'm going to use the trig ratio here. So I'm going to use the trig ratio, and I'll use the opposite and adjacent side, which is slope, so tan. So I'm going to say that tan of 35 degrees is equal to rise over run, or opposite over adjacent. The opposite side is that m side, which was 5.79. The adjacent side is our unknown side. That's the side we're looking for. And that's going to be equal to, well, I have to convert that tan ratio into, the angle into a ratio. So I'm going to need my calculator, and I get about 0.700, or the rise is 70% the length of the run. And then I'm going to solve this algebraically. A times 0.700 is equal to 5.79. Okay, so I'm going to multiply both sides by A to get rid of the divide by A. And to get rid of the divide by 0.700, I'm going to, times by 0.700, I'm going to divide. So I end up with I'm getting 8.26. Okay, so if you're somewhere around 8, that's pretty good. You're doing the right thing. Okay, so 8.26. Okay, so I'm going to add that to the n value. Those two together, the A, which is this length here on the blue right triangle, and n is the length on the red right triangle. If I add those together, I end up with the length of y. So y works out to be, I'll write it over here, so my length of y is equal to A plus n, 8.26 plus 6.89. My y value I'm getting is 15.15. Okay, so there it is. 15.15 represents the length along this line right along here. That's length of y.